Hey guys, this is Mr. Grice for Algebra Unit 9.6 Notes. Today we're talking about piecewise functions. Our learning target today is to be able to graph piecewise functions containing linear, quadratic, absolute values, and square root functions. Let's go ahead and begin. So take a look at our definition. A piecewise function is a function composed of pieces of other functions. Okay? So it's composed of pieces of two or more functions, okay? And they kind of make pretty cool graphs. Let's look at example 1. What two graphs do you see? Let's look at the blue one first. Now the blue one, it makes a shape of a V. That is a absolute value. And what about the one in the red? Well, the one up 1, remember, if you don't know, look at the pattern. Up 1 over 1, up 1, right 3. That is a square root. Okay, let's look at example 2. What are the two graphs that's composed of? In the blue, we have it's a parabola, which means it's a quadratic. So we have a quadratic, and in the red, we have absolute value. Why don't you guys try to do number 3? Well, the blue is a quadratic. I don't know, do you guys remember what the one on the red is? It's just a straight line, and if it's just a straight line, that means it is linear. Okay? So, and what we're going to be doing is we're going to be graphing both of these together. So, rule number 1, you should be writing in a pencil today, okay? Pencil, 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 pencil. What you want to do, graph the vertex or initial point and lightly draw each function, because we're going to be erasing part of this, okay? And that's where step 2 is, says erase the piece that is not within the given domain. Okay, and then make sure the endpoints of the functions follow the rules of inequalities, okay? These two symbols are open and those two are closed. So we're kind of reviewing and throwing a lot of different things together. So let's look at our first function right here. What can you tell me about it? First, I want to know what type of graph that first part would make. Well, it would be quadratic. Okay. Is it reflected? Yes or no? Okay, it's not reflected, so that means it would be positive. And then the next thing I want to know is our vertex. What's the vertex for this graph? Well, it would be positive 3, 2. Okay? So what we're going to do is we're going to graph that. And I'm going to graph this in blue. Okay? So my vertex is at 3, 2. So I'm going to go to 3 to the right and 2. And then I go up 1 over 1, up 1 over 1, up 3 over 1, up 3 over 1. Okay, and then I would graph. Okay, but we need to pay attention. Let's see, this is what we did, and then here is our constraint. X is less than 4. So at 4 right here, I'm drawing my little line. I want what's less than that. And less means everything to the left. Okay? So I don't need that point And our other point, since it's open, or it's just less than, that's going to be open. Okay? So our new line now, our new graph, is going to look just like that. Okay? So that's just our first graph. But now we have to graph our second one. Okay? And I'm going to graph this guy in red. So, first part, what type of graph is it going to make? Okay, this is going to be a square root. And is it going to be reflected? No, it's not going to be reflected. And then our initial point is 4, 5. Okay? So, at 4, 5, that's where we start. So 4, 5. Okay, and then I go up 1, over 1, up 1, right 3. Okay? And there we go. Now, the reason why my red point at 4, 5 is closed is because at x is greater than 4, so at right there, it's greater than or equal to. So it's closed. Okay? Now, our domain. Remember, our domain is our x value. And are there any limits to x? Is there any limits saying that I can go so far to the left or so far to the right? Well, if I go to the right, that's what the function's telling me to do, the square root function. And going to the left, even though this goes straight up, it's also going to go wider and wider and wider. Okay? So there's no limit on our domain, so x is all real numbers. What about the range? Is there a limit to how high it goes? Well, what about how low it goes? Well, yeah, does it ever go below that point? No. Since it doesn't go below that point, this is our limit. And what number is that? That's a 2. Okay? So our limit for our y is y has to be greater than or equal to 2. Now, the last thing we have to do is find the value of f of 5. So when our x, remember this is talking about our x value, when our x value is 5, this is 5 right here. What's that? Okay, and that's 6. Okay, so when we plug in f of 5, we should get 6. All right. Now the question is a function has to pass the vertical line test. How does that pass? It hits 2 points on top of each other. Okay. Now the reason why it passes is because this is open, which means it's not equal, and our other point is closed. Okay. So that's why it passes the vertical line test. All right, let's go ahead and look at another example. So here's our first equation. Now, what type of line is that going to give us, or graph? Okay, that's a linear. And we need to know our slope. When we're talking about linear, our slope is 2 over 3, which means we have to go up 2 and to the right 3. And we start at 0, -6. Okay, so let's go ahead and do that. At 0, -6, then I go up 2 over 3, up 2 over 3, up 2 over 3. And remember that we need to go in both directions. Now, before I draw my line, I'm going to look at this. So I need to be at 3. I need to be less than 3. And less means the left. Okay? So those 2 points don't matter to me anymore. And right here at 3, I need to be open. Okay? So then go ahead and draw your line. Make sure you're using a ruler or your ID. And there's our first part of our graph. Okay? And that's the graph that's in blue. Now, what type of graph is that going to be in gray? Remember those bars? Those bars mean absolute value. Okay? All right, and the next thing we need to know about absolute value, is it reflected? No, it's not reflected. And then our vertex is 5, 1. Okay, so I go to the point 5, 1, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I need to do that to the left as well. But once again, I have to remember that I only want things that are greater than 3. Okay, so I only want things that are to the right, which means I don't need those points. Okay, and since it's greater than or equal to, it's going to be closed. So there's our graph. Okay, now let's work on the domain. Are there any limits to the x going left or right? No. So no limits, it's all real numbers. What about the y value? Well, our quadlinear one, it's going to keep going down, and our absolute value is going to keep going up. So since there are no limits, our y value for the range is also all real numbers. Okay? And the last one, find f of 0. So when x is 0, what does it equal? Okay? So when x equals 0, what did you get? Okay, you get negative what? That's negative 1, 2, negative 6. All right, let's flip it over. Number 3. See if you can graph number 3 all on your own. Go ahead and pause the video, and good luck. Okay, that's what you should have gotten to for the quadratic. And the reason why I stopped at the 4 right there is because that's what the limit told me. It said I want less than 4. So I want everything to the left on that graph. Okay? Let's look at the next one. What type of graph is that? Well, that's going to be an absolute value. Is it reflected? No, it's not reflected. And then what's our vertex? 7, negative 4. Okay? So at 7, negative 4, that's where I'm starting. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4 is where I start. And I just go up 1 over 1. Whoa, look at that. It's actually filling in the other point, and that's fine. I'm going to stop my graph there because I want everything that is to the right. Okay? So let's go ahead and do the domain and range together. The domain, there's no limit, so it's going to be x is all real numbers. And for the y, Is there a limit to how low it goes? Yeah, it doesn't go below that point. And that point is specifically -4. So y is greater than or equal to -4. Okay, so what's the value of f of 4? Well, 1, 2, 3, 4. What does it equal? It equals -1. Okay. Oop, I forgot to mark that that was our red graph. Okay, so this one's going to be my red graph. This one's going to be my blue graph. So what we'll do this time is we'll go through and write the information down, and I want you guys to graph everything, okay? So the one on the top, that is a linear, good. So when we're talking about linear, I need to know my slope, and my slope is 1/3, which tells me up 1, and then to the right 3, and then we start at 0, 1. Now the gray one, that is also a linear, and our slope is -2/3, which tells me I have to go down 2 and to the right 3, and we're starting at 0, 7. Okay, so I want you to graph this and just pay attention to what our limits are supposed to be. Okay, so go ahead and pause the video, and good luck. Okay, this is the line, the two functions that you should have drawn. Okay, now what was hard about the red one is because our initial point was at 0, 7, and you would have had to connect those to figure that out. But once you remember that, hey, I can only draw right of 3, you should have erased those. Okay, so our domain would be that x is all real numbers because there's no limit. And let's talk about the y. What do you think? All real numbers? Or is there a limit to how high it goes? Well, is there anything above that line? No, which means there's a limit that y is less than or equal to 5. Okay? And the last one, find the value of -3. At -3, which is 1, 2, 3, our value is 0. Okay, number 5. Why don't you guys answer the questions to number 5, and then I'll let you graph them. Okay, so let's pause the video, answer those real fast. Okay, so that's the first couple things that you should have written. The top one, the blue one, okay, that's a linear. -2, 3, and 0, 1 is our starting point, and then our red one is a quadratic. Remember, it's reflected because of that negative, so that's why it's going to be going down, and our vertex is the point 2, 1. Okay, so what I want you to do is go ahead and pause the video and see if you can graph these all on your own. Okay, remember to pay attention to our limit right there. Okay, pause the video and good luck. Okay, there you go. That's where you should have drawn your two graphs. And then our domain is all real numbers from left to right. And then our range for this one is actually the same thing because there's no limit to how high or to how low it goes. Okay. At f of 1, what did we get? Oh, you know what I just noticed? I started my graph, my quadratic, at the wrong point. 2, 1 is up here. Okay, so you guys have to pay attention to that. Thankfully, I can do that really fast. Okay, so at 2, 1, or at f of 1, remember, because that's our x value, we get 0. Okay. Well, guys, I know this was kind of new, so if you have any questions, especially with the domain and range, please come see Miss Carranza or myself. We'd love to help you out. Your homework is the 9.6 practice. Okay. Good luck. If you have any questions, come find us. This is Mr. Grice signing off for Algebra Unit 9.6 Notes. Thanks for watching.